children, to do this, I want all of you to keep your calculators in your hands, because I will tell you as I go along with these notes. I want you to check values, right? So I will tell you, children, check this value, check this value. You all have to put it into your calculator and check it with me. All right, so keep your calculators in your hands and let's learn trigonometry. All right, okay. So children, first of all, now there are children who have done trigonometry before and there are children who have not done trigonometry before, right? So I will explain this as simply as possible for all of you to understand, right? So those who don't know trigonometry will learn it, and those who already know, your understanding will get better, all right? So children, there are three main trigonometric functions. They are also called trigonometric ratios, children, right? So sometimes you will see the word trigonometric ratio, right? In higher grades especially, you will see trigonometric functions, right? So they are the same thing, right? So don't worry about that. The first one is the sine function or the sine ratio. The second one, children, is the cosine function or the cos ratio. And the third one is the tangent function or the tangent ratio. Right, so I just want to remind the admin, don't let anyone else in from the waiting room. All right, okay, so children, let's move on. So children, the three different trig functions, sine, cosine and tangent, in short they are called sine, cos and tan. So if you look at your calculator, you will see that there's sine, cos and tan buttons on your calculator. All right, so that's what they are. Okay, then children, these three functions, right? Okay, so Panchali says there will be a new student who will come now. So Puta, let me know her name and I will let her in. Okay, right. So these three functions can be used to, her name is Imashi. Okay, so admin, if someone named Imashi comes, just let them in. All right, all right, she's here. Okay, right. So yes, children. So as I was saying, sine, cos and tan can be used to perform operations on right angle triangles. All right, so we'll be looking at that. And children, these functions, they take angles as their input and they output a value, children, right? Their input is an angle and their output is a value. Okay, so we'll have a look, we'll see what that is. So we'll first learn how to name a right angle triangle, children, right? How to name a right angle triangle. So this is a right angle triangle, right? And children, can you see I have marked one angle, right? So you can see the right angle is there clearly, right? And I also have another angle, theta, right? That is what we call the angle in focus. So this is important, children, because all the other sides of the triangle we are going to name relative to the angle in focus, right? Also, children, if you haven't seen this notation, this letter theta before, so you know how we use x in equations to denote an unknown value, right? And we solve it to find x. So similarly, children, when there is an unknown angle, we use the Greek letter theta, right? It's theta. We use it for an unknown angle. So if you haven't seen this before, this is just a new notation, children, right? For an unknown angle. Okay. Now, children, let's name the sides. Now, if you look at this angle in focus, children, the side which is opposite the angle in focus, right? So when I mean opposite, I mean on the other side. The angle in focus is here. The opposite is the side on the other side, the opposite angle. We always call it the side opposite the angle in focus, children, right? That is the side opposite the angle in focus. Then, children, we have this side which is called the adjacent side. So you all know what adjacent means. Adjacent means something that is close to it or next to it, right? So the side that is next to the angle or with the angle is called the adjacent side, right? So it is the side adjacent to the angle in focus. Then, children, finally, we'll go to the last side, the longest side. It is the hypotenuse, right? It is always the side opposite the right angle, and it will always be the longest side of a right angle triangle, children. right? Children, remember, if the angle in focus becomes the other angle, this opposite and adjacent will switch, but the hypotenuse will stay the same, right? So for example, children, if this becomes the angle in focus, then this becomes the opposite and this becomes the adjacent side. Am I right? But the hypotenuse will stay the same. Okay, so keep that in mind, right? So now that we know how to name a right angle triangle, let's move on to the trigonometric functions. First, we have the sine function. So children, the sine, so we have a right angle triangle here, right? So I have, instead of writing opposite, adjacent, hypotenuse, I've just marked them with the letters, right? Children, the sine function is the ratio of the length of the opposite side divided by the length of the hypotenuse, right? The length of the opposite side divided by the length of the hypotenuse, that is the ratio of sine, right? So in short, we can say that sine theta is equal to O over H, or opposite over hypotenuse, right? Now children, here's a right angle triangle, right? In this right angle triangle, right, so I have drawn this to scale, children, right? So if that side is 1 and the hypotenuse is 2 and the angle is 30 degrees, this length will come to 1.732. So I have drawn this to scale. Okay, so children, you can see here I take sine theta, which is opposite over hypotenuse. So the angle in focus is the 30-degree angle, and from this angle, children, the opposite is 1, the hypotenuse is 2. Can you see that, children? Right? Now, if I substitute, the angle is 30. So sine theta is sine 30. Opposite is 1, hypotenuse is 2, so you get half. Right? So children, I want you all to take your calculators and type sine 30 and see what you get. You all should get half, or 0.5. If there is anyone who gets a different answer in your calculator, please let me know, right? So when you type sine 30, you all should get half or 0.5 as the answer. So children, that means you can see that, so Anne got a different answer, and do a check. You must be on a different mode. Your calculator has been degree mode, right? There is a little light on top of the calculator with a D or an R, right? So make sure that the D light is on and not the R light, right? So you can switch that mode. I think you can press shift and then mode, and it will give you the options to switch. Yes, so there you go. So try it with degree mode, right? Shift and then mode, and you can go to degree mode, and now you can try sine 30, right? And you should get 0.5. Let me know if you get it, right? So children, you can see, yes, it's short as degree. Yeah, that's the one, though. Yes, that's degree, right? So children, you can see this ratio of sine 30, this function gives me the same value as the ratio of the two sides, right? Can you see that, children? Right. Okay, so I think Andu also got the right answer. All right, so children, let's go to the next function, the cos function. So children, again, I take the same triangle. Children, this time, remember, cos theta gives you the distance of the adjacent side divided by the hypotenuse. Adjacent divided by hypotenuse. I can write this as, in short, A over H, adjacent over hypotenuse. Again, let's take the same triangle. Now, earlier we took sine theta. This time, let's take cos theta. So children, cos theta is adjacent over hypotenuse. The adjacent is 1.732 and the hypotenuse is 2. Now I want you to take your calculator and first input cos 30 and check the value. Input cos 30 and check the value you get. After that, divide 1.732 by 2 and see the value, and see whether your value is the same if you do both. Right? So children, if you all do it correctly, you should get 0.866 from both. Right? Cos 30 will give you 0.866, just to 3 decimal places, huh? Right? Cos 30 is 0.866, and 1.732 divided by 2 will also give you 0.866, children. All right, this is the value. If any of you get something else, please let me know. All right, a different answer. Right, good. So you all have got the answers. Good, very good, children. The tan function. So again, same triangle. Children, tan is opposite over adjacent. It doesn't use the hypotenuse. Tan is opposite over adjacent. So O over A. If we use the same triangle, children, you can see we have yes. So Senelidua is giving us a easy way to remember this these three. I will explain that at the end of this as well, right? So children, for tan, the angle here is going to be 30, opposite is 1, right, and the adjacent is 1.732. So now children, take your calculators, type tan 30, see what is the answer you get, and then type 1 divided by 1.732 and check your answer, right? Do both and see. Yes, correct, Semalia. The answer you got is correct. 0.577 would be the answer you get from both sides to 3 decimal places. So can you all see, children, this sine, cos and tan, these ratios nicely give you the lengths divided by one another, right? So now, just like Senolidua said, I will show you an easy way to remember these, children, right? There is a nice catchy word that we can memorize, right? It is called so, right? Toa. It is called Sohtoa. So what is this Sohtoa? Sohtoa stands for SOH is sine theta is opposite over hypotenuse. S stands for sine. O and H is opposite over hypotenuse. Then children, cos is adjacent over hypotenuse, right? And finally, children, toa is tan is opposite over adjacent, right? So you all can remember it as Sohtoa. So children, quickly take this down because you all will need this when you all are doing the questions today, right? So take it down. I'll give you a minute. Children, is it clear up to this point what we have done so far? So the three different ratios. So I haven't explained how to use them in questions yet, right? But we will look at that as well. Okay. Yes. Yes. So only though you have said you wanted to see the cos slide and the tan slide, I will show it to you, right? So children, I hope that you all have taken this down, right? Okay. So I'll just show you the cos slide and the tans. So here's the cos slide first, right? Take a screenshot though because there is no time to write it down, but I will send you these slides anyway, right, in the WhatsApp group. Okay, so that is the cos function slide, right? So I'm going to do further questions with sine, cos and tan, so don't worry about it. And this is the tan slide. Is that okay, Onali? Right. Okay, now children, how to use this? Now how does this benefit us? Now that's all fine, right? Because we get the perfect answer, that's fine. But how is this useful? What do we do with these? Let's have a look. So children, look at this triangle here, right angle triangle. Angle in focus is 29 degrees. The opposite is unknown, x. Adjacent is 7. Children, which of these three functions use opposite to hypotenuse, children? Sorry, I said adjacent is 7. The hypotenuse is 7, right? So children, which of these functions use opposite to hypotenuse? Answer now. Yes, sine. Yes, that is correct. It is the sine function which uses, very good children, sine function uses opposite over hypotenuse, right? So we use the sine function to try and figure out this unknown side x. Okay, so what do? We know that the angle is 29, right? We know the angle is 29. The opposite side length is x and the hypotenuse is 7. So I substitute those different values. Now children, remember, I need to find x. So what I do is I multiply both sides by 7. The 7 in the denominator, I take it to the other side with sine 29, and therefore children, I get x is equal to 7 times sine 29. Now I want all of you to take your calculators and type 7 sine 29, right? So I'll show you what I have done as well, like this. 7 sine 29. If you like, you can put a multiplication sign after the 7 as well, right? And I want you to enter it and tell me what value you get. Yes, so if you do it properly, right, to 2 decimal places, your answer will be 3.39. Very good. All of you got the right answer. Very good, children. Excellent. Can you see we found the length of the unknown side, right? That is how you find the length. Let's do another one. Here's another triangle, children. Okay, now get ready. We have 27 is the angle in focus. This time we have the adjacent is the unknown, x. The hypotenuse is 11. Children, what function should we use? Which function uses the adjacent and the hypotenuse? Cosine. Very good, Nitara. Yes, so everyone is saying cosine. Very good. Right, so let's use cos. So cos theta is equal to adjacent over hypotenuse. So theta is 27 this time. Adjacent is x. Hypotenuse is 11. So what do we do, children? We take the denominator 11 and we multiply it with the cos 27 on the other side. So that gives us x equals to 11 cos 27. Children, type 11 cos 27 in your calculators and get the answer. Right? So Ovindu has already sent me the answer. Netmi has also sent me the answer. Nitara said, yes, all your answers are correct, children. Excellent. Right? So can you see? You can use this to find the unknown side lengths. Right? You can use it to find the unknown side lengths. Then we'll do another one. Now children, I have twisted this triangle a little bit to confuse you, but you can see the right angle is clearly marked and the angle in focus is 69 degrees. Children, this time the opposite is x and the adjacent is 38. So children, which function uses the opposite and the adjacent? Yes, correct. Tan is the function. Very good. Very good, children, right? So therefore we use tan theta is equal to opposite over adjacent, right? So the opposite this time is x. The adjacent is 38, right? So tan 69 is equal to x over 38. Then children, we move the 38 to the other side. So you get x is equal to 38 tan 69. Children, can I have the answer? What is the length of x? Yes, Ovini, that answer is correct. Right, good. So you all may have different rounding values, but yes, your answer is correct. So to 2 decimal places, the answer would be 98.99. So some of you said 99 after rounding it off, right? So that is also not wrong. Okay, so to 2 decimal places, this is the answer. So children, did all of you get this very clearly? If there's someone who didn't understand this, please let me know. Right, so it's very crucial that you understand how to do this. Okay, Senali says all clear. Very good. Onali says got it. What about the others? Ovini understood. Very good. Children, is there someone who didn't understand? That's what I want to know. Good. I'm getting a lot of messages saying they got it. Okay, children, I'm very happy. Very happy. Okay, children, okay, good. Very good, children. All right. So let's go on to something else. Now, this is interesting, children, right? So pay attention. This triangle here, 33 is the angle in focus, opposite side is 21. This time the hypotenuse is unknown, right? The hypotenuse is unknown. Which function should we use, children? If we know the opposite and we have to use the opposite and the hypotenuse together, which function would we use? Sine. Very good, Nitara. Yes, so everyone is, yes, so it is sine, right? Correct. Very good. It is sine. Right? Remember, opposite and hypotenuse together is sine always. We'll take sine theta equals opposite to a hypotenuse. Now, children, the angle is 33. So, sine 33 equals, so this time opposite is 21. Right? And the hypotenuse is x. Now, what do we do, children? Remember, you have to make x your subject. You have to make x your subject. What do? You take the x to the other side and multiply it with sine 33. So x sine 33 will equal 21, right? I'll write that down as well, right? X sine 33 degrees will equal to 21. Then children, you bring the sine 33 down, right? Because we want to make x the subject alone. You bring the sine 33 down and you get x is equal to 21 over sine 33, right? So children, I want all of you to take your calculators and type this in. 21 over sine 33. Take a fraction first, right? Take a fraction first. Numerator 21, denominator sine 33, right? And then enter that into your calculator and press equals and give me the answer that you get. So I already have, I'm already getting answers. Very good. Very good, children, right? That is the correct answer. The correct answer to 2 decimal places would be 38.56. I think everyone's saying 55. Let me just confirm. Children, to 2 decimal places, it will be 56, huh? Careful. Yes, so Netmidu has sent the right answer. Senulidua, you get an error probably because you didn't close the bracket in the sign at the denominator. So for some reason in the calculator, if you enter sign and not close the bracket in the numerator, then you don't get an error. But if you put it in the denominator and don't close the bracket, you get an error. So try closing that bracket and see Senulidua whether you get the answer. So Anne says, I think I have round it. So yes, now of course we will round the answer, right? So the question will tell you whether they want it to 2 decimal places or 3 decimal places or whatever. So you will have to give the answer to that, right? Okay, so Senoli got the answer there as well. So that was the issue. Okay, so children, that is what you do. Now let's do another one. So one more, right? So children, this question has opposite and the adjacent, right? So the opposite here is 10.3 and the adjacent is x, and so we have to use tan because of opposite and adjacent, right? So children, the angle is 75, so we have tan 75 equals to opposite, which is 10.3 divided by x. Now you move the x to the other side, multiply with tan 45 and you bring the tan 45 down, so you get x is equal to 10.3 divided by tan 75. Right? So children, enter this in your calculator and tell me what you get. Right. Yes, children, your answer is correct, right? You get 2.76 as your answer, right? So now children, that's the end of finding an unknown side. So if you all have any questions about finding the length of an unknown side, please let me know now. If it's not clear to anyone, let me know. Is it clear to all of you? It's clear? Okay, so I'm going to assume that it's clear because you are not sending me any questions. Yes, so yes, Dua, I can explain the last one again, right? So last one meaning this, the tan one that I did, right? Yes, so what's happening here is we have a triangle, a right angle triangle, and the angle in focus is, sir, you and I put the brackets, I still get 2 points. Yeah, so 2.7, that value is correct, no, Dua? Right? Yes, so anyway, now I think Preksha Dua asked me this question. So Dua, we have a right angle triangle, right? And we have the angle in focus as 75. The side opposite that is 10.3 and the adjacent is the unknown. X is the unknown. So we know that when we are working with opposite over adjacent or anything to do with an opposite and an adjacent, right, you have to always use tan, right? So that's why I take tan theta equals to opposite over adjacent, right? So 75 is the angle, so I put tan 75, right? Then my opposite is 10.3, so I put that in the numerator, and the adjacent is the denominator, so I put x there. Then what I do is, now there is a step that I actually skipped here, right? So you multiply this x with the other side, you get x tan 75 degrees equals to 10.3, right? Then you take the tan 75 down and you get this one, right? You divide by tan 75, you get x equals to 10.3 over tan 75. So now you can put this whole thing in your calculator. You can take the fraction, put 10.3 in the numerator, tan 75 in the denominator, make sure you close the bracket, press equals, and you should get that answer. Prekshadwa, is it clear? Let me know.
Sandra teacher, Anne
Yes.
has mentioned that she got 38.55. So 38.55, 7 is the
Yeah.
7, 6 like it goes, right? So it's 5, 7 is there. So therefore you have to round it to the second decimal place and it becomes 5, 6 and.
Yes. So Netmidu has explained it correctly. She says round
Yeah,
it to two decimal places. So the answer is 38.557. So to two decimal
yeah.
places becomes 562. Yes. Right? Okay.
And children, don't worry about this rounding things. We will be explaining this when we are doing the papers, because normally the Excel papers, they mention three significant figures. Cambridge also, they specify sometimes and they give decimal places mostly, right? So we'll be discussing this thing. Don't worry about it.
What is significant figures and what is decimals? Isn't that right, Deline teacher?
Yes, yes.
Okay. So children, sir, then where do we do inverse? Yes, do it. So now I'm going to show you the inverse. Right? Okay. So children, now this is all well and good. But what if you have to use the sides to find the angle? Now comes the problem, right? So if we need to find an unknown angle, children, now we learned how to find the unknown side. To find an unknown angle, we use inverse trigonometric functions. So let's look at what are inverse trigonometric functions. So children, we learned that sine theta is opposite to hypotenuse. Children, to get theta, right, you get sine inverse opposite over hypotenuse. So children, this is how you write sine inverse. The way you write it, you write sine and you write a little minus 1 as a superscript, like you write powers, like x squared, right? Like a power, you write a minus 1 as a tiny superscript on top. That means sine inverse opposite to a hypotenuse. It means sine. So then when you use the sine inverse function, children, it is the opposite function. It is the inverse function that will give you the angle. All right. So I will show you examples how this is done. Right. So for now, I want you to have a look at this closely. Right. So then cos we learned was adjacent over hypotenuse. So children, to get the angle, you do cos inverse adjacent over hypotenuse. Right. Similarly, children, tan is opposite to over adjacent. So the angle is tan inverse opposite to over adjacent. So children, you will see in on your calculators above the sine cos tan buttons in yellow, most probably you will have some writing which says sine inverse, cos inverse, tan inverse. So to access them, children, you press the shift button and the sine, shift button and the cos, or shift button and the tan. Alright, try it and see, children. Try it and see whether you all can get the sine inverse, cos inverse and tan inverse. Right? You press shift and sine, cos and tan. Okay, that is how you get those. Right? Okay, good. Good. Alright. So children, take this. No, I think there's nothing to take down actually, because this is pretty straightforward. Yes, and do it should be. Remember, all of you, your calculators have to always be in degree mode. Right? You all don't
Yeah,
use the other modes until A levels. Right? So
yeah,
all,
radians, you will get a wrong answer.
yes, you will get very wrong
Yeah.
answers, children. Right? So don't change the mode on your calculator. Leave it in degree mode. Okay? Right. Now, children, let's look at some examples. How to find an unknown angle. Right? Okay. So, children, here's an example. So we have the angle in focus is given, but we don't know it. It's an unknown, right? We know the opposite is 3, the adjacent is 6. So children, if you know the opposite and the adjacent, sorry, not the adjacent, the opposite is 3, the hypotenuse is 6. If you know the opposite and the hypotenuse, what function should you use? Ovini says sine. Correct, Dua, right? So you all know that it should be the sine function, right? Opposite and hypotenuse. Right. So let's see. We take sine theta equals to opposite over hypotenuse. Now theta we don't know, so we leave that as theta, right? So you leave that as sine theta. For opposite you can put 3, for hypotenuse you can put 6. Now children, 3 over 6 is a fraction that can simplify. It becomes half, right? So you get, now you take the sine inverse, children, right? So you have sine theta equals half. You take the sine inverse. Now you get theta equals to sine inverse of half. Now I want you all to take your calculators, right? Get sine inverse. So press shift and then sine, right? And press the and enter half and give me the answers. That so you're already sending me the answers. Yes, yes, so all your answers are correct, right? That's right, children. The answer is 30. So, Deline teacher, they have already got the answer. I don't have to explain this, I think. Right?
Yeah.
Yes, good. So, children, let's try another one.
And yeah,
Yes.
and children, 30 degrees, you have to put the degree sign.
Ah, yes.
Okay, it's a
Don't
must
forget
that you
it,
have
children.
to mention the sign.
Yeah, it's like writing units, isn't it, Deline teacher?
Yes,
Yes.
yes.
Okay. So, children, here's another one. Now, here we know the angle. We don't know the angle. But we have been given 7, which is the adjacent, and the hypotenuse is 9. So children, which function do we use if we know the adjacent and the hypotenuse? Cos. Correct, right? We use the cos function. So children, we take cos theta is equal to adjacent over hypotenuse. So the adjacent is 7, the hypotenuse is 9, right? So we'll take 7 over 9. Now children, you take theta is equal to cos inverse 7 over 9, right? Now children, put this into your calculator and tell me your answers. What do you get? Yes, 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 children. So I have given my answer to just one decimal place, right? So your answers are correct. So all of you are saying 38.94. Very good, children, right? Very good. Okay, we'll do a last question. Here we have the opposite is 100, the adjacent is 120, right? Which function, children? Tan function. Correct. Very good, right? So children, tan theta is opposite over adjacent, and we have opposite as 100, adjacent is 120. Children, remember 100 over 120 can simplify. So Tharuli is asking, sir, should it be rounded to one decimal place or two? Though it will be said in the question. So if the question says to one decimal angles, I think most of the time it's one decimal place, but it can be two decimal places also. So depending on the question, they will ask you to round it off to that number, right? So then you can give the answer. Okay, so children, 100 over 120 simplifies to 5 over 6, right? Remember that. So I can take theta is equal to tan inverse 5 over 6. So children, even if you put 100 over 120 in your calculator, it's not wrong. You will get the same answer, right? So I already have two answers from Ovini and Oneli, right? What about the others? Yes, very good. Very good, children. So the answer is 39.8 degrees. Very good, right? So that is the answer. Okay. Now, children, I have explained about how to find an unknown side and unknown angle, right? So before I explain, before I go on, so I also have two other topics lined up for you, bearings and angles of elevation and depression. So before we go into those two topics, if you all have any questions about this, you can ask now. If it's not clear to anyone, please ask. Children? Okay. All right. Everyone is quiet. All clear, sir. All right. Very good. Children, let's go on to, right. So it seems that all of you all have understood. Very good. So children, we learned how to find using trigonometry. Now you all know what is trigonometry. Using trigonometry, how to find an unknown side and find an unknown angle. Yes, do I will send the PowerPoint. All right. Okay. Bearings. So children, will quickly discuss this as well, and we'll go on to our questions, right? So children, some of you may already have done bearings, right? Let's have a look. What is a bearing? So children, now let's go away from trigonometry for a second. We will come back to trigonometry, I promise, right? So children, there are 4 cardinal directions. Now everyone here has heard of the 4 directions. What is it? North, south, east and west. You all know the directions, right? So north and south everyone can remember, right? So east and west, how I remember it is west rhymes with left. So west is on the left side, east is on the other side, right? So you all can remember that way, right? Now children, this is a map of north, south, east and west, right? Now children, when we talk about bearings, this is what we mean. A bearing is the direction of one place from another using due north as the reference direction. So children, when we describe a bearing, we use north as the reference and we give the angle of one place from another, right? That's what we do. So for example, though, children, we commonly use 3-figure bearings, right? Where north is 0, 0, 0. So that means, children, the north straightforward is 0, 0, 0, right? And we measure all the other angles from north, right? So let's have a look. Now I have a detailed map. Here I have not only the 4 main directions, but I also have the 4 sub directions: northeast, southeast, southwest and northwest. I'm sure they all have heard of these directions, right? So children, remember, north is 0, 0, 0 degrees, right? Northeast is 45 degrees, children. Can you see? Because it is 45 degrees from north in the clockwise direction. Remember children, we never go anti-clockwise in bearings. We only go clockwise. You all know what clockwise means, yes? It's the direction that a clock moves in, right? So when we go clockwise from north 45 degrees, we go to the northeast direction, that is 45. The bearing is 45. If we go to east, that is 90 degrees from north, children, right? 90 degrees from north. If we keep going another 45 degrees from east, we go to 135 degrees and that is southeast. If you keep going another 45 degrees, children, you get to 180 degrees. That's a straight angle. Remember, a straight line has an angle of 180 degrees. So the direction south will have a bearing of 180 degrees. Let's add another 45 degrees to go to southwest, right? So that is 225 degrees, right? From north clockwise, 225 degrees. Another 45, west is 270 degrees, right? Another 45 to northwest is 315 degrees. If you add another 45, children, you get 360, which is one full circle. So remember children, in bearings, 0, 0, 0 and 360 are the same, because one full circle will, if you turn one full circle, children, you will end up facing the same direction, right? So if you turn one full circle from north, you will end up looking at north, right? So this is how you measure bearings, right? Also children, very important, we call them 3-figure bearings, right? So 3-figure bearings, if you are writing an angle less than 100 degrees, children, write a 0 in front, because you have to write 3 numbers, 3 figures, right? So if it's only, say for example, now 45 and 90 here, you can see I've written a 045 and 090, right? Okay. So children, Senulidua is sharing with us saying she remembers north, south, east, west as never eat spider webs. Okay, so I think all of you will remember this now, right? Never eat spider webs. So north, east, south, west. Never eat spider webs. That goes clockwise. So that's very good. Even I have never heard of that. Thank you, Senulidua, for sharing. Okay. Now, children. Okay, so now everyone is sending different examples. Naughty elephant sprouts water. Yes. So there are many things that you can remember. All right. So children, let's look at a question. Now have a look at this diagram, children. So there are 2 towns. There's town A and town B, right? And you can see that there is an angle between them as well, right? And the north direction from both towns is marked. All right. Now children, to find the bearing of town B from town A, remember, town B from town A, very important. That means you're standing at town A and you're looking at town B. What do? You stand at town A, face north and turn clockwise until you are facing town B. The angle you have turned through is the three-figure bearing of town B from town A. Let me repeat that, children. You're looking at town B from town A, right? So you'll face north and you turn clockwise until you are facing town B. The angle that you have turned through is the three-figure bearing. So I think it's very clear. Here you have to turn 74 degrees from the north to look at town B from town A, right? So therefore the bearing of town B from town A is 074 degrees. That's the three-figure bearing. So that is straightforward. But what about the bearing of town A from town B? Now the other way around, right? So children, you stand at town B, okay? Face north, 0, 0, 0, and turn clockwise until you are facing town A. So now you have to turn quite a large angle. Can you see? Because you can't turn anti-clockwise. You have to go clockwise, right? So the angle you turn through is the three-figure bearing. So children, now we have to find this angle. We can find it like this. We extend the two lines, right? We extend these two lines north. So in the south direction, we can extend the lines. Then children, you all will realize that these two lines are parallel. And because this line in the middle is, we call a transversal line that cuts across two parallel lines, right? This angle will be 74 because they are alternate angles, right? So you all probably remember that, right? Alternate angles from parallel lines. Then children, you all also know that this side is 180 degrees, isn't it? It is 180 degrees because it's a straight angle. So if you add these two together, 180 plus 74, it turns out that big angle is 254 degrees. Which means, children, that the bearing of town A from town B is 254 degrees. Children, is bearings clear? If anyone has questions about bearings, please ask now. So because I'm done explaining bearings.
Yeah, Sanun teacher,
Yes.
sometimes actually the normally they learn the other way as well, right? This is correct.
Yeah.
The allied angle thing also just explain, because if they are used to that also, then they think
I'm
this
sorry,
method.
Dilati, I didn't quite hear you.
The allied angles, the interior angles 74, then the
Ah,
other side is
yeah. Okay.
360.
Yes. So children, uh, this angle is the one that Dilani teacher is talking about, right? Because see, these two lines are parallel lines, right? So you can see there's a U shape here. Can you see? I think you can't see that color. Let me do it in red. Can you see the U shape, children? So you all know that from two parallel lines, if you take a U shape, these two angles should add up to give you 180, right? So from 180, you can subtract 74 and you can get this angle here, and you can subtract that from 360 to get 254, children.
Yes.
Right? Yes.
Both ways are correct, children.
Yes, so Netmidua has used another method where she got the 74 from an alternate angle, then she subtracted by 180 and then subtracted from 360. So children, you can work around as you like, as long as you get the right
As
answer.
long as
Right?
yes.
Okay. Yes. So Onali Dua wants me to explain how I got 74 again. So Dua 74 is from, so you see these are two parallel lines now, right? Can you see this is the Z shape? Alternate angles, right? So if it's an Z shape, this angle and this angle are going to be equal. Did you get it though? Onali? Yes, okay, she got it. All right. So children, any other questions about bearings? You can ask now. No questions. All right. Let's go on to angles of elevation and depression, children. Okay, so children, this is very easy, right? I won't take a lot of time to explain this, right? So children, angle of elevation is this. Now look at this diagram. So imagine you're standing at the angle E. So we have the ground level and we have a vertical pole, okay? And there's a right angle, obviously, right? So children, the angle through which you raise your eyes to look up at an object higher than you is called the angle of elevation, right? So children, now in this example, you can see from ground level, you're looking up at the top of the pole. That is the angle of elevation from the horizontal upwards, this angle E, right? In this diagram, the angle of elevation is labeled E. So now children, imagine you all are at home watching TV. If you all are sitting on the floor, right? If you're sitting on the floor and watching TV, aren't you looking up at the TV, children? Right? So that is the angle of elevation from the ground up. That is the angle of elevation. If you're looking up at something, that angle is called the angle of elevation. It's this E, right? So children, also notice the right angle triangle formed by the top of the pole, right? So the top of the pole is here, the base of the pole, and your position, this one. So you can see this is a nice right angle triangle with the right angle here, right? You can work out the angles and lengths of this triangle with trigonometry. Now we learned how to do that. You recognize the triangle, you can use your sine, cos, tan knowledge now to find these unknown lengths, right? So let's look at an example like that, right? So I'll go through this quickly, children. So I have the same diagram. So let's say the pole is 2.5 meters high and you are standing 3 meters from the base of the pole. What is the angle of elevation? So let's say, children, the pole is 2.5 meters. Your distance is 3 meters from the pole, right? So you can see from this angle E, right, the opposite is 2.5 and the adjacent is 3. So if it's opposite and adjacent, children, we use the tan function, right? So that means tan theta is equal to 0 over A, sorry, or opposite over adjacent O over A, right? Tan E is going to be 2.5 over 3, right? So you can take tan inverse 2.5 over 3 and easily find the angle of elevation to be 39.8, right? So children, this is angle of elevation, right? There's another one similar called angle of depression, right? So children, angle of depression is this. If you're looking down at something, right? Let's say you all are standing on your balcony and looking down at someone, right? So someone's on the ground floor. You all are looking down from the horizontal. That angle you're looking down is called the angle of depression. So if you look at this diagram, right, you can see this person, he's standing on the cliff and he's looking down at the ship which is on the sea. So he's looking down at sea level. So that angle with the horizontal that he's looking down through, that is called the angle of depression, right? So again, children, you will notice that there is a right angle triangle formed by the ship, then the vertical length from the ship to the horizontal, so that means this point here, and your position. So that means, children, you get a right angle triangle like this, right? And again, using sine, cos, and tan, you can work out the lengths and angles with trigonometry, right? So again, let's look at an example from that as well, and then we'll go to the questions. So children, let's say the top of the cliff is 300 meters above sea level. So that's where you are, 300 meters above sea level, and the angle of depression to the ship is 25 degrees. So this time we know the angle of depression. How far out at sea is the ship? So here's the information, right? So the height is 300 meters, right? And the angle of depression is 25, and the distance from you to the ship is x. So I'll take it as x because that's the distance I don't know, all right? So then, children, again I use tan because I have to use opposite over adjacent, right? So I use tan 25 equals to 300 over x. So I can work this around. Now you all know how to do this. You can enter it in your calculator and get the answer. So that means the ship is 643 meters out at sea. Okay, right. So children, any questions? So this is the end. This is the end of today's lesson, right? So we learned trig, bearings, angle of elevation, and depression. If you all have any questions, ask me now before we give you the paper. Any questions? Answer is no questions. All clear. Very good though. What about the others? Any questions from anyone else? Okay, seems like no questions. All good, all clear. All right, very good, children. Okay, all right. So, children, I'll send you the homework sheet in the chat. I'll also send it in the WhatsApp group. So, Deline teacher, how much time can we give them?
Because they're using the calculator, we'll reduce the time, no? 15 minutes?
That's fine.
Children, are y'all okay with 15 minutes? Or y'all want more? Okay. Children, another small request is there from me. Will you be able, y'all are in a group, right? WhatsApp group. If you don't mind, can you please make some comments about this class? Because actually to make the other children encouraged to share in the groups, that's why we want that. So if you don't mind, if you can comment about this class, right? In the WhatsApp group, yes, in the WhatsApp group. It will be a great help, and you're also getting merit because we are trying to get more children to the class. Okay. Thank you
Also,
so much.
so I have a request from one doer who wants me to explain bearings again. So, yes. So, children, go ahead with the questions now. Okay. So, there was one doer who wanted me to explain bearings again. So, I will explain it to her. Right, children, you all go ahead with the questions. If you understood it, that's fine. Right. Okay. Right. So, doer who asked me to explain this. Now, I'll just go through it. Children, you all can mute the computer. Come back in 15 minutes. So, we'll give you until 4:55. Okay. You have till 4:55. Okay, we'll quickly
All right.
discuss the answers after that.
Yes, Handun teacher, can you just
Yeah,
let me know, because these children cannot share any comment in the group, isn't it?
yeah, that's right, Deline teacher, because only the
Then
admins are allowed to
how
send messages.
how can we get the comments?
Mm, we'll speak with Swamin Mahasensi, I think, and we'll see if there's a way that we can get their comments, Miss Deline.
Yeah, I will. I
Yeah,
will. I
yeah,
will.
right. Yes, children, don't worry about it. So, children, go ahead with the questions. So, thoroughly, Dua, you wanted me to explain bearings again, so I'll just go through it, right? So, Dua, in bearings, right? Let me go to the bearing slide. Okay, so it's like this, right? So when you're looking at bearings, you always start from north, right? So bearings is always going to be between two places though. Okay, right? So Tarlito, could you send me a message and let me know whether you're here? Yes, okay, right. So the others go ahead with the questions, okay? Right. So Dua, now we look at, now let's say you're standing, we'll say in from Colombo to Kandy, Dua, right? So let's say you're in Colombo, okay? And you want to find the bearing to Kandy, right? So we'll say like this. Now, let's say this is your position in Colombo. And let's say Kandy is somewhere here, right? You want to stand. Now we first mark north from both Kandy and Colombo, right? So this is the zero bearing, right? That's the north. Now you stand in Colombo and you're looking up. You're looking up meaning you're looking north, right? You're looking north, and what you do is from north, right? You turn clockwise. You know what clockwise is, right? The direction that the clock hands stick. You turn slowly until you are facing Kandy, right? So when you're facing Kandy, the angle that you turn will be this much. Am I right? That will be the angle that you turn. So let's say this angle is, we'll say 30 degrees, for example, right? I don't know, right? Let's say it's 30 degrees. Then what happens? You can say that the bearing of Kandy from Colombo, the bearing of Kandy from Colombo is 030 degrees, right? That is bearing. Got it? Now on the other hand, let's say your cousin lives in Kandy, right? Let's say your cousin lives in Kandy and your cousin is looking back at us, right? So bearing would she look at? Now let's say your cousin is in Candy. She also turns clockwise. Remember, she doesn't turn this way. You can't go that way, right? You always have to go clockwise. So she turns slowly, slowly, slowly until she's looking at us from the clockwise direction. Now she has turned all the way. Now she's looking at Colombo, right? So the angle that she has turned to look at Colombo, right? That is the bearing of Colombo from Candy. So we can find that angle though, because these two lines are parallel and always both lines are facing north, right? So that means this is going to be 180. This angle is 30 and this other angle have to add to 180. So that means this angle is going to be 150, because 30 plus 150 is 180. So therefore 360 minus 150, right? You can get this angle as 210. So that means the bearing of Colombo from Candy is 210 degrees. Did you get it now, though?